Hello and welcome back to episode number 7 of my world map tutorial series. Today we want to add the feature of undiscovered areas so that there are certain places on our map that are hidden from the player until we discover them. And the basic idea is to simply put a black circular gradient on top of the actual map texture to hide these areas, and then when we discover them we would simply play a little animation to fade that circle out and then remove it entirely. Let's start with creating the widget for this black circle. If you've had a look at the asset pack before, here in our textures, you'll notice that there is no texture for the black circle we're going to create. And there is a good reason for that, because we don't really know about the sizes of these areas, since that will depend on a variable. And if you were to use a texture, you would have to scale that up and scale it down, which would lead to a massive loss of quality. So we can't use a texture for this. Instead, we will manually create this black circle using a material. And the advantage of that is that you can scale it up and scale it down infinitely without losing quality. So let's go to our world map system folder and we'll create a new subfolder for materials. Let's go in there and right click to create a new material. Let's call this m_undiscovered area and open it up. First off, the current material domain is set to surface. Let's hit the drop down and select user interface, since that is the only place where we ever want to display this material. Now you see that you've got access to the final color and screen position. However, we also want to get access to the opacity. So under blend mode, we'll select translucent and the opacity pin will light up. Then to get the basic gradient, there is a node here called radial gradient exponential. Let's get this and simply plug that in for the opacity. Then for the final color, we will simply take the gradient and look for multiply. You can hook up the multiply node to the final color. Then we'll just hit 3 and left click to create a 3-dimensional vector. So here we can simply specify the default color of our gradient. I'll just use white and connect that to the multiply node. We apply that, we can already see a little preview of our material. Right now this gradient is way too translucent, and to get more control over what your gradient looks like, there are two parameters here, the radius and density that we'll modify. So let's hit 1 and left click to create a constant and hook that up to radius and do the same thing for density. Then we can simply select our two constants and modify the values. So for radius, I figured out that 0.5 works pretty good. And for density, I chose a value of 7. If you then apply, you see that your gradient now is a lot more dense, and only at the very edge it is going to fade out. So that is exactly what we want. And don't worry about the color here. Currently that's white, but we can later set it to black in our widget. So let's save and close our m_undiscovered area. Then let's create the widget for it in our widgets folder. So user interface, widget blueprint, and simply call that w_undiscovered area and open it up. This widget here will also be put in our world map widget, so you can set it to desired on screen and remove the canvas. There are only two elements we need in here. First off, a size box. And this size box actually needs to be a variable, so let's check the is variable and call it something like size box. We can check the width and height override and set it to any value you want, maybe 100 pixel by 100 pixel. These values here really don't matter because they will dynamically change anyways. And then let's grab an image, drag that onto our size box. We can uncheck the is variable. And for the image here, simply select your material. So m_undiscovered area. And under color and opacity, we can simply make that black now. We didn't make it black in the material itself because then the color and opacity setting here wouldn't be able to change anything. And now you could also pick another color if you don't want to go with black like I do. So for example, you could use green or something. But we will simply go to black and hit OK. So that's it already for this widget. Later when we remove it, we want to smooth that out a bit. So slowly fade out the opacity of this widget. Let's add an animation for that and call it fade out. If you then double click your animation, you get access to the timeline. And the value we want to animate is when we select our W undiscovered area in the hierarchy, it will be the render opacity. So let's add a keyframe at 0 seconds with an opacity of 1. Then let's say over 2 seconds will fade out. So go to 2 seconds, set it to 0 and hit the keyframe button again. So now you just get a simple fade out animation. And just in case the animation messed up some of the values, let's close and reopen the widget. Yep, it did that. So select your widget in the hierarchy and reset the render opacity to 1. So that's it for designing this widget. Let's hop over to the event graph and add some functionality. So first off, we want to dynamically modify the size. So let's add a variable called circle size. And let's make that a float. Editable, exposed on spawn. If we compile, we can give it a default, let's say 100. Then let's add a function called update circle size and give it one input of the type float, which will simply be the new size. Then what we have to do is very simple. We just update our variables, so set it to the input. And then to actually modify the size of our widget, we will simply set the width and height override of our size box. So grab your size box and set width override, hook that up to the execution, then set height override. And for the in value, we will simply grab our circle size and connect it to both pins. Then we can compile and save this function. Back in our event graph, we will implement the event pre-construct and call update circle size, with the new size being our circle size variable. That just means that we could hop over to the designer, select our undiscovered area, and if we play around with the value here, you can see the size increasing. And you might have also noticed that we're not using quality because we're using a material for the circle. Let's reset that to 100. And let's add a custom event here called remove widget, which will simply play our fade out animation. So play animation and select fade out as the in animation. Then once that animation is completed, we can simply destroy this widget. So let's add a delay node. And to get the duration of your animation, simply drag off of it and look for end time. Plug that in for the duration. And once that is completed, we'll call remove from parent. That's it for the functionality of this widget. We can compile, save and close our undiscovered area. And we need a way to attach undiscovered areas to the world map. So let's go in there. We no longer need the animations and timelines. So the idea is that when our game starts, we will check for all of the undiscovered areas in the world and then dynamically add them to the map overlay here. However, there is a little problem with that because then it would be displayed on top of our player box. And depending on when we add the undiscovered areas, it could be on top of some markers. So that is not something we want. The fix here is very simple. You just grab an overlay and drag that onto your map overlay. Then set that to fill. We will call this here the areas overlay and make it a variable. Then we can simply rearrange it. So we want it to be on top of our background, but beneath the player box. And then instead of adding the areas to the map overlay, we will add them to the areas overlay. And that way our player box will always stay on top of them and markers will do the same thing. Let's hop over to the graph and add a function called add area to map. Then this needs two inputs. So first off, we want to know about the size of the area. So let's make that a float called size. And the second one will be a vector 2D, which will simply be the position of it. The logic is very similar to the add marker. We simply create a widget and select our undiscovered area as the class. It will already be asking you for the circle size, so that is where our input here feeds in. Then we need to add this to our areas overlay. So add child to overlay and hook up the return value as content. Then, so that we also use the position input, we'll drag off the return value and set render translation to the input. After that, we can return. And let's also return the widget we created. So select your function, add an output, of the type W underscore undiscovered area reference that we'll simply call out, and hook up the return value of your create node to that. Then let's compile and save, and we can close our world map widget. I already told you that we will have actual representations of these undiscovered areas in the map, so let's also create a class for that in our actors folder. So new blueprint class of type actor called BP underscore undiscovered area, and open it up. In here we basically need 2 collision spheres, so let's add the first one, sphere collision, and we'll call that the area sphere. And let's go to shape and pick an orange color here, just so that we can distinguish between the 2 spheres. So let's add the second sphere, sphere collision, and that will be the discover sphere. And make sure that it's not attached to the area sphere but to the default scene root. For the discover sphere, we can also go to the shape color and make that something like a light blue. So the reason why we need 2 different spheres is that the first one here, the area sphere, will be the whole area on the map that will be covered by the black circle on the map. And the discover sphere is just a second collision sphere that when we enter it will reveal the area. So by default that would be a bit larger than the area sphere, and once you've entered it, the whole area will be revealed. Let's add some variables to do that. So first one will be area radius of the type float, editable, exposed on spawn, and we can actually put that in a settings category. Then add another variable called additional discover radius. So the word additional here already points out that the discover sphere is usually bigger than the area sphere, and also editable, exposed on spawn in the settings category. Then we can compile and give them some default values. So area, let's say that will be 500, and additional discover radius will be something like 20. To apply these values to the spheres, we'll head over to the construction script, drag in our area sphere, and set the sphere radius. Plug in the area radius, and we don't need to check for overlap, so simply uncheck it. And after that we'll get the discover sphere, set the radius of that too, again uncheck update overlaps, and here the radius will be the area radius plus a float, and we will add the additional discover radius, then the result of that will feed in here. We compile and save, head over to the viewport. You can already see the orange outline of the area and the blue outline of the discover sphere, which is just a tiny bit larger. Finally, let's go to the event graph here and add a custom event called Undiscovered. And for now, the only thing we want to do is destroy our actor. Compile, save. That's everything we can do in here for the moment. So let's minimize the BP undiscovered area. And we will now open the BPC world map. To start with, we will need a variable to keep track of all of the undiscovered areas. So hit the variable button, call it undiscovered areas. The type of that will simply be BP underscore undiscovered area object reference, and we'll make that an array and private. Then we also need to keep track of the corresponding widgets, so our black circles. Let's call that area widget, and here the type will be W underscore undiscovered area object reference, and it will also be an array and private. We somehow need to figure out a way to convert the radius of an actual undiscovered area actor to the size of the circle on the map. So let's create a function which we will call area radius to map radius, even though here the radius isn't exactly correct because we will use that to drive the circle size and the radius would only be half of that. So let's call it area radius to map circle size, and this takes in one input of the type BP underscore undiscovered area object reference called area, and it will return a float which will be the size. Then we can make it pure, and what we will do here is we will drag off of the area and get its area radius, the variable here. Then we'll multiply that by 2 because the radius is only half of the size of a circle. And after that, divide it by another float. We want to divide that by the map width and hook that up. And then we will multiply the result by a float, which will simply be the size of our map. So get your map reference and simply look for get map size x. Then hook that up to convert it to a float and plug that in for the size. By the way, if you're wondering, you don't really have to use the map width. You could also use the map height and then replace the size in x here by the size in y. That would give you the same result. So with that function created, we need a way to somehow gather all of the undiscovered areas in our world when the game starts and display them on our map. So let's do that in the event graph in our initialize map event right here. Before we try to show the map, let's move that somewhere here. And we will call get all actors of class. Class will simply be our BP underscore undiscovered area. Then we can set our undiscovered areas variable to the result and run it for each loop. Once that loop is completed, we can proceed with our functionality from before, so showing the map and adding it to the viewport. Then here in our for each loop, for every area that we found, we want to add a widget. So grab the map reference and add area to map. Then to figure out the size, drag off your array element and look for area radius to map circle size and hook that up. Then to grab the position, we already implemented a function for that. So location to map position, hook that up. For the location of your array element, we can simply get the actor location and plug that in. And for the widget size, we'll make a vector 2D and hook up the circle size for x and y, because that is exactly what the size of this widget will be set to. Okay, once we've added the area to map, we can grab our area widget and add an element here, which will simply be the return value of our function. And that's it already. So let's compile, save, close our BPC world map for now, and place BP undiscovered area somewhere in our world, maybe to our second platform here. And we'll just increase the area radius so that the whole platform fits within. Then we can hold Alt and drag out a copy, maybe somewhere here. And let's make that a lot smaller, so maybe something like 400 will work fine. Then if we were to play and open up our map, you can actually already see the two circles appearing. However, right now, if we were to approach them, they will not be discovered. So that is what we need to fix right now. Let's open up our world map component. And in our event graph, let's look for some room. Here we'll add a custom event called Undiscovered Area. This will take in the area that has been discovered, so a BP undiscovered area reference. Simply call that area. And first off, we need to check whether that area really is undiscovered. So drag in your undiscovered areas, look for contains, plug in the input, and add an if statement of the contains. If it's true, we'll copy over the undiscovered areas array and we will try to find the input. Okay, so that is the index at which we found it. We can promote that to a variable called area index and make sure to make it private. Hook that up to true. We're just storing that here in a variable. So if this was a function, you could make that a local variable. Off of your undiscovered areas, we can remove index and plug in the area index. After that, get your area widgets and get from that at the area index. So that should be the corresponding black circle for the area we're trying to remove. Let's check whether that is valid, though it should always be. And if it is valid, drag off of it and call the remove widget function. So that way it will play its little fade out animation. After that, let's copy over the area widgets array and remove an element. So remove an index actually. The index still being the area index. And here at the very end, we will drag off of our input and call the Undiscovered event. Hook that up to remove index and we'll also connect that to the is not valid path. Okay, let's compile and save. Right now we need a way to call this event once we overlap the Discover sphere, so that we can only do in our BP Undiscovered area. Let's select the Discover sphere and scroll down, then implement the onComponent begin overlap. Let's check whether the actor that is overlapping owns a map component. So off of the other actor, get component by class. Type here will be BPC world map, and check whether the return value is valid. If it is, let's actually go into a do once node so that the following logic is only executed once, and drag off the return value again and call on discover area, with the area being a reference to self. Okay, let's compile and save. Then if we play and open up our map, you can see the circle right there. If we were to approach the area, it would slowly fade out. Okay, and the same thing is true for the smaller circle over here. Alright, so discovering areas is already working fine. Actually, an issue at the moment is, if we have a look at our circles and zoom in, we can see that again the position and size is not updated. Let's fix that in our BPC world map. If you remember, for the markers and player icon we made it variables, so keep player size when zooming and keep marker size when zooming. For the areas that does not make sense, because if we were to keep the size when zooming, it would simply no longer be correct. So you could see parts of the map that you're not supposed to see. Let's add a function called update area sizes and positions, and here we will simply get all of our undiscovered areas and run it for each loop. Then we need to check whether there is a widget for it, so area widget, and get a copy at the array index. Check whether what you get here is valid, and if there is a widget, we can simply call the update circle size function. The new size simply being our area radius to map circle function, plug in the array element as the area and the size as the new size. Maybe you're wondering why this function here works right out of the box, because we're not taking into account our current size multiplier, but indirectly we're already doing that. If we have a look at the function, we are multiplying our result here by the map size in X, and that value actually is based on our current size multiplier. So that's why this function here works out of the box. And off of your array element here, we will also set render translation to update the position. And here we also have to call location to map position function and plug that in. Location being the actor location of our array element. And the widget size will still be a vector2d, so make vector2d, with the circle size feeding into X and Y. Compile and save. The only thing left would be to call this function when zooming, so we'll go into our modify map size function, and at the very end here, right after updating the marker positions, we will update area sizes and positions. Then go into the return node, and that should already work. So if we compile and save and play, open up our map, we see our two circles here. If we zoom in, the size is maintained and the position also updates perfectly. The last feature I want to add is actual fog in the level, so that the area is not only hidden on the map but also in-game. We need a particle system for the smoke. Fortunately, we included starter content. Let's go to particles, and here we already got the p_smoke, so that is similar to what we want to achieve. Let's right click and duplicate that to p_area smoke. And then we'll go in there and make some small modifications. First off, we don't need velocity here, so we'll simply remove that. This way the smoke will emit in a circular way because we're using a sphere module. And here we'll go into the start radius, distribution, and increase that to something like 100. So that's our new radius. Then we'll go to spawn, because we need a lot more smoke particles so that it feels dense. Go to rate, distribution, and set the spawn rate to 50. Then we'll go to lifetime and reduce that by a bit. So currently it's set to 5 in min and 6 in max. We'll set that to 3 seconds minimum and 3.5 seconds maximum. Then we'll go to the constant acceleration and increase the Z to 50 maybe, just so that it moves a lot faster. Finally, we want to make it dark smoke. So we'll go to color over life, expand the color over life here, distribution, constant curve, then expand the points and element 0 and 1. We only want to modify element 0, so simply go to the out value and select a very dark gray, almost black here. Then hit OK, and that should already be it. We can close it, and let's put that in our level. It's already looking good. We could make it a bit darker. So let's go back to the color over live and say we want to make point 1 complete black, and go to point 2 and make that also a bit darker. Then if we have a look at the level again, yep, that looks fine. We can remove it because we want to attach this particle system to our actual blueprint. So open your BP Undiscovered area, and here in the viewport we will simply add a particle system component. And because I selected the area smoke in the content browser, it already used that as the template. Rename that to particle system. You can also call that smoke if you want. Let's say we want to make it a setting whether this smoke should be displayed. So let's add a variable called show smoke, question mark, of type boolean, editable, exposed on spawn, and in the settings category, say by default it is true. And now we want to make it match the size of the area sphere. The way you can do that is by grabbing your area radius and figuring out which value matches the default size of your particle system. So simply decrease the area radius until it completely encapsulates the smoke particle system. I figured out that an area radius of 150 works pretty fine. And then we can use this value in our construction script. So we'll grab our particle system, set relative scale 3D. And to get this scale, we simply grab our area radius and divide that by the value we just found out. So the 150 in our case. Then we can clamp that just to make sure it doesn't go below certain values. And we will say the minimum would be 10% of the original size, so 0.1, and a maximum of 100 maybe. Then you can simply plug that in for the new scale 3D. If we head over to the viewport again, right now the size matches, and if we grab our area radius and increase that, you see the size of the particle system is also modified properly. We can reset the area radius to 500, which was the default value. And in our construction script, let's also set the visibility of a particle system to whatever our show smoke setting is set to. Currently it's only setting the visibility, but if show smoke is false, we can actually entirely remove this component when the game starts. So head over to the event graph, to event begin play, and let's add a branch off of the show smoke. And if it's false, we simply drag in the particle system and destroy the whole component. Then when the area is discovered, we actually don't directly want to destroy the actor, because if our particle system is playing, we also want to slowly fade out the smoke. So grab your particle system and look for is valid. It would not be valid if it was removed on begin play. If it's not valid, we can simply destroy the actor immediately. But if it is, we can grab our particle system and deactivate it. Deactivating means that it will stop spawning new particles, and the already existing particles of it will be destroyed according to their lifetime. Then after it, we can wait for a couple of seconds, so use a delay. You could actually set that to the maximum lifetime of particles here if you want to make sure that no particles will be destroyed before they stop playing, but I'll just use a value of 2.5 seconds. That will work fine in most cases. And once that is completed, we can also go to the destroy actor node. Okay, let's compile and save. We can close our classes, and you can already see the smoke in our level. Let's scale up the area radius here. And if we were to play, we can see a smoke both in the actual level and the black circle on the map. If we zoom in and out, the size of it maintains the same and the position is updated. Then if we were to discover this area, you can see that it slowly fades out on the map and in the level. And the same thing happens here. So that was exactly the behavior we wanted to achieve. And it's the end of this episode. The next one will actually be the last episode of this series, in which we will add waypoints to our map and enable our player to fast travel to them. So thanks for watching and see you next time.